Hello everyone. In the last session we have started unit number 7, that is Earth segment. We have covered receive only home TV system and community internet TV system in the last session. In today's session we will see what do you mean by master antenna TV system, digital DBS TV receiver, and the transmit receive Earth station. First of all, we are focusing on the master antenna TV system. You can see from this diagram, over here outdoor unit and indoor unit are there, okay, as similar to the receive only home TV system. But the only difference is the indoor unit in receive only home TV system has only a one receiver. But over here we are able to see that there are a number of receivers. Alright. So first of all, the outdoor unit consists of parabolic reflector, or you can say parabolic dish antenna, and low noise amplifier, or you can say low noise block converter, and in the indoor unit it consists of power divider, channel group selector, multiple receivers, and multiple modulators. So this is the possible arrangement of master antenna TV system. Okay, we will see one by one the outdoor unit and the indoor unit. But before starting indoor and outdoor unit, what is the use of this master antenna TV system? As if we want to use a single antenna on the rooftop of our home, or you can say the terrace, and if we are going to connect a number of TVs in different rooms, then we are going to use this master antenna TV system. Alright, that's why the signal which are going to receive with the help of this parabolic dish antenna is going to be focused on this horn, which converts a specific frequency into either a left hand circular polarized channel and a right hand circular polarized channel group. Why we are going to separate out this left hand and right hand circular polarized channel? The reason is we are dividing this channel into two parts, because we are going to first divide it and then it is going to be selected with the help of channel group selector. Alright, that's why polarization duplexer is used to convert the channel into left hand circularly polarized as well as the right hand circularly polarized channel, so that channels are applied to the indoor unit. And the first block of indoor unit is power divider. With the help of this power divider, its outputs are going to channel group selector, because we are able to select the channel based on the requirements, and that group of channels are given to the receiver, as multiple receivers are receiving the channels. That's why we can access a TV system in different rooms with the help of only a single outdoor unit, or against a single parabolic reflector. And that signal is going to be modulated, and we are able to see our audio and video on our TV system. Okay, so there are only one parabolic reflector, and there are multiple receivers, or you can say multiple set-top box which are connected to the multiple TVs. All right. This is the example of master antenna TV system. Okay. Now, what do you mean by digital DBS TV receiver? So, for a digital receiver, only the earth segment which deals with the digital inputs, which are basically which modulated, it is basically a QPSK, quadrature phase shift gain modulated signal, or we can also use another modulation system. But if we consider that our bandwidth is 24 megahertz and our roll-off that is factor is zero point 0.2, then what is the symbol rate? To calculate a symbol rate, the equation is bandwidth divided by 1 plus roll-off rate. Okay, bandwidth is given at is 24 megahertz, roll-off rate is 0 0.2. So we can say that our symbol rate is, that is R symbol is 20 mega symbols per second. With the help of this digital DBS TV receiver, we can receive a 20 mega symbols per second based on the bandwidth. Okay. Now these are the different bit rates for digital DBS TV receiver. So this is the television formats, ATSC television formats. Now what do you mean by ATSC? ATSC stands for Advanced Television System Committee. And these different formats are like high definition television, standard definition television. Okay, so each and every formats are having a specific resolution and specific bit rates. For example, if I am considering the HDTV, it having a screen ratio of 16:9, it's having a pixels like 1920 cross 1080 and having a bit rates respectively for SDTV as well as for SDTV. Okay. Over here, a P stands for progressive scanning, I stands for interlace scanning, that we have already studied in audio video system. What do we mean by interlace scanning and progressive scanning? All right. Now, this is the block diagram for InDo Unit, this one. And as we know, this is a standard block diagram for outdoor unit. Okay, so outdoor unit consists of 12 to 12.2 to 12.7 gigahertz frequency. It is going to be received with the help of parabolic reflector, and it is focused with the help of horn, and then it is going to be given to a low noise amplifier or low noise block converter. Okay, InDo Unit consists of tuner. It is for frequency selection. Then that frequency is going to be demodulated and error is going to be corrected because this is in the form of digital signal. Okay, and that signal is going to be demultiplexed. With the help of demultiplexer, we are getting the output in the form of audio and video. Okay, and this controlling had been done with the help of microprocessor. The data will be stored in the memories. Okay, at the output we are getting the audio as well as the video. So this is how we are going to convert our digital signal into audio and the video form. Okay, now our next and the last topic of unit number 7 is transmit receive earth station. Now transmit receive earth station provides a transmission and the reception function which are required for telecommunication traffic, which includes in network TV. Okay, you can see over here the baseband interconnection panel. This is the switch And over here you are able to see that same blocks are present, but these are the dark one, these are the dotted one. So if there is a failure in any of the block, then with the help of this switch we are able to transmit our signal or switch our signal to the redundant blocks. Okay, for transmitting portion as well as for the receiving portion. So above portion is the transmitter, below is the receiver. All right. So these are the different basic elements of redundant earth station. All right. Over here, the first block at the transmitting side is modulator, which are used to transmit the signal to the longer distance. That's why we are going to use a modulation. That means we are going to superimpose our information signal onto the carrier frequency, or you can say higher frequency, right? It is going to be up converted with the help of mixture, and it is going to be amplified with the help of high power amplifier. And over here switch is there. If you want to select the signal which is coming from upper portion, or you can say for lower portion. Okay, signal can be either present on upper or lower. All right, and that is going to be transmitted with the help of antenna. Over here duplexer is there. That means our single antenna will works as transmitter as well as the receiving antenna. Okay, now as the signal is going to be received through this receiving antenna, a duplexer will connect to the this receiver portion. Okay, now in the receiving side, the first block is LNA, that is low noise amplifier, which are used to maintain our signal to noise ratio at the maximum. Okay, then the signal is going to be divided with the help of power divider. The standby chain is redundant, as we have discussed earlier, that if any of the block is not operated or not functional properly, then our signal is going to be switched to the remaining blocks. Okay, the signal is going to be down converted with the help of mixture. Then the same, it is demodulated by demodulator with the help of switch. Signal is coming over here on the baseband interconnection panel. So this is the block diagram of transmit receive earth station. Okay. Now this is the more detailed block diagram of transmit receive earth station. Over here you can see that this is the antenna, this is the duplexer, this portion is for transmitter, this portion is for the receiver. Over here you can see that this is the up converter. Transmitter consists of power amplifier, combiner, up converter, modulator, multiplexer, and the baseband equipment, or you can say equipment for connection to the terrestrial network. What do you mean by terrestrial network? Terrestrial network means ground-based network. Okay. So the terrestrial network baseband inputs and outputs. These are the inputs which are coming over here. It is going to be multiplexed with the help of multiplexer. Then it is modulated to transmit a signal to the longer distance. Again, the frequency is going to be up converted or increase with the help of up converter, and the different channels are going to be selected and combined with the help of combiner. As the signal is going to be traveled to the longer distance, it's going to be attenuated. That's why we are going to transmit the signal in the amplified version, okay, with the help of power amplifier. Now we are going to transmit the signal with the help of transmitter. Over here duplexer is there. As duplexer is connected, We are only using the single antenna. Okay. As I'm going to transmit a signal, duplexer will connect the antenna to the transmitting portion. Right? Now, that signal is, as I'm going to transmit a signal, transmitting antenna will going to be activated. And as I'm going to receive the signal, this duplexer will connect the antenna to the low noise amplifier, this portion. Okay. So this is our transmitter and this is our receiver, TX and RX. The first block of any receiver is low noise amplifier, then it is going to be divided, then it is down converted. That means we are going to decrease the frequency, demodulated, and again we will receive the signal for terrestrial network. So these are the inputs, these are the outputs. So interconnection equipment is required for interconnecting the satellite station and the terrestrial network. Okay, so must required for TX where a kind of reformatting is maintained. Alright, and the modulators which are used at transmitting side, it can be quadrature phase shift key or quadrature amplitude modulation. Up converters, which is implemented to up convert the frequency. Ideally, it was IF frequency was 70 megahertz, and for RF it is 6 or 14 gigahertz. And the carriers which are combined, which resulting in the wideband signal is going to be amplified. It's transmitted through transmitting and receiving. All right. So over here, chapter number 7 is finished. So if you have any question, you can ask me at any time on my email ID that is mentioned over here. Thank you for your attention.